Hey everyone, what is up? I got a fresh bits release here. Not really a commute, not really a seasonal episode, but really just kind of an interstitial. And I've kind of been working with a little bit of new code over the weekend. I kind of got a wild hair late last week, and I thought, I wonder how hard it would be to create a new transport for mass transit using gRPC. So play with me here for a second. So I started thinking, how could I do a non-durable peer-to-peer, point-to-point transport that basically is in memory, so similar to the in-memory transport, but that can communicate between nodes. And then I started thinking, what could that enable if I could actually have multiple services communicating with each other via its own backplane, in this case using gRPC, and what would that look like and what would it feel like? So I did a lot of grinding over the weekend. I got a lot of bits done. I actually have a NuGet package published. So what I'm going to do is I'm going to walk through this little sample app I have, and I'm looking for feedback on how we could really get kind of cool with gRPC here. So bear with me. This is just going to be kind of a walkthrough of the code and kind of give an idea. It's mass transit. So if you already are familiar with mass transit, it's exactly the same thing. It's the same programming model. It's the same pub/sub programming model. So let that bear in. It seems like a lot of the peer-to-peer transports don't really have kind of a pub/sub, or maybe they do and I just don't know it. But when I think of gRPC, I think of send and receive and request response and things like that. And what I'm really trying to enable is that pub/sub RabbitMQ fabric without the broker. So I think this could be kind of cool. I think it could unlock a lot of scenarios, especially for back-end type stuff. But anyway, I'm going to dig into this. Give me some feedback on this. Hit us up on the Discord. Feel free to leave comments in YouTube, but Discord's really the fun place to hang out. There's a link in the description to get to the Discord server. A lot of activity on there all the time, so definitely check that out. Bring your feedback in. Play with the bits. Let me know what you think. So this is seriously a fresh nugget. I mean, it just came out. Not 13 minutes ago. Let's refresh. Surely not. Surely it's been out for more than 13. Okay, 28 minutes ago. I mean, this is about the freshest NuGet you can get. It's still a develop, so you got to turn on pre-release to see it. But let's look at what we have. I've created a simple console app that adds mass transit. I do some silly things like kebab case, everything you would do. Add a consumer. But you'll notice here in big bold letters using gRPC. So the gRPC is one of the new transports that I put together. And for this demo, I've put a few configurations options in it. Every node running gRPC is a host. Servers can connect to it via gRPC. And in this example, I'm going to run multiple instances of the app, one of them acting as an instance of mass transit running the submit claim consumer, which does a response back to the submitter or to the sender saying that the claim was submitted. So I'm doing a full request response. I could also do a publish and event subscribe, whatever I want to do there. But I wanted something that would show that I can actually write back to the queues on the other node, so that it's bidirectional. It's always on connected. So I have some config stuff here. The mass transit hosted service, my claim submission service. This is the one that actually does the request and response, and in this case I just do 10 request responses to the service, getting the claim back and just doing it in a loop. So the client is going to show claim submitted as outputting the response data, and the consumer is going to write submit claim out, and it's going to show the source address in each case where that came from. So I'm going to do a quick run of this, and I'm going to start it up, and we can see it's going to start up. I'm starting the bus. With the gRPC transport, our bus endpoints are HTTP IP address host. And in this case, I've used 1979.6 as the default port that I'm using. Perfect. Bus starts up. Endpoints are ready. I have the submit claim endpoint for my consumer, and I have the bus endpoint, which is created for every bus, which is that 127.001 1979.6. Application is started, up and running. Great. I'm going to jump over to my other window, and in this one, I'm passing one additional argument. I'm saying, in addition to running the host, connect to another server and form that mesh network. So I'm going to connect to that 1979.6, and this one I'm going to say my port is 1979.7. Now by specifying these servers, I'm also telling this that I want to start sending requests. So that's going to come up, and we're going to see that it's going to start the bus. It's going to do a gRPC connect to that other instance. And now I'm doing request and response locally with this service. The service doesn't know that the service is on. This is actually using publish for the request. You can see that it's sending to URN message contract submit claim. It's sending to the exchange via publish the request, because I didn't specify a destination address, and that request was actually processed and the response sent out by the first instance of the service. So two separate instances communicating via gRPC in the background. The application doesn't have to know anything about it. It just works. If you wanted to actually do like a get send endpoint with the HTTP address, you could totally do that and send directly to the queue, and it would end up on the service that's hosting that queue. So the mesh in the background is handling all the message traffic. You don't have to know or deal with client-side ports or any of that. You only use MassTransit primitives. I am only using the request client in here. So I only am just saying, get response of claim submitted, passing that submit claim. I don't know where anything is running. I don't care. It's just working. And it works like MassTransit. The MassTransit in-memory transport was built to be like RabbitMQ. And the gRPC transport is a fork of that in-memory transport, because I didn't want to break in-memory. And I wanted to add the capability to share that topology and build that mesh across all the nodes. So I think this is pretty cool because I don't have to know, and I can get like a fully in-memory peer-to-peer broker, in quotes, working between the machines. Now I can do this with multiple services as well. In fact, let me kill this. So, and the thing is, I can do this more than once. When I disconnect, the original application, the original server sees that that client disconnected, it parted. I'm a join part, IRC. Part was how you left a chat. It's just my brain. And I can go back and run this again if I want to, and it'll reconnect. And because it's reconnected, it knows it's the same address. It flushes the old topology so that it doesn't lose. So it doesn't duplicate, so I'm not getting two responses because I have now two versions of that node. It cleans up the topology nicely. And you can see I get the same messages reconnecting. It doesn't matter which order I start these up in. It just sort of connects, and you can see all the endpoints stop, submit claim. You can see that I ran the app twice. I had 20 messages received. All the debug messages you expect to see are there. Another demo I put together was just a quick Docker container that has two services. So this is putting them on completely separate IP addresses, in this case node 1, 2, and 3 within Docker. So I have a Docker compose that's going to build those up. I don't know if it needs built or not. We'll see. Of course it needs built, even though I just built it, but whatever. We'll let it run and do its thing. Once it builds up and restores those packages, we'll get the image. All three are using exactly the same image. And you can see the nodes are coming up. They're each calling submit. They're each doing the same request response, but they all just came up different IP addresses, different ports. You can see in this case, the name is node 1, node 2, and node 3. In this case, they're all having different IP addresses, but with the same host port of 1979.6. So how I pick that number is 1979 plus 6. Why not, right? Okay, it's easy for me to remember. Perfect static port to use. And you can pick any port number you want. You just need to know it to connect to it, because that's the way servers work. But yeah, so there I have two nodes, two separate Docker container images running against that first Docker image that's actually hosting the submit claim service. So I'm going to keep this short. I think this is a great intro. Like I said, the nuggets out there, nougat, whatever. Yeah, it's just cool to say fresh nuggets. You know, kind of cool. You know, I think it's a gem, nugget gem. Yeah, okay, no, that would be Ruby. Never mind. Sorry, I'm getting slap happy. It's way too much code over this weekend. Definitely give me some feedback on this. We have our next morning commute this Tuesday, so 2 mornings from now, not tomorrow morning, but Tuesday morning. It's 7 a.m. Central Time, so check your local times. We're currently, I think, on Central Daylight Time. But we'll be doing that in the Discord channel, in the Morning Commute voice channel, so definitely drop in. It's a good way to just kind of ask questions about MassTransit if you need help, or we just kind of talk about ideas and shoot the breeze for an hour. It's at 7 a.m. Central Time. But let me know what you think. I think this could be pretty cool. I'm pretty excited about it. That's why I wanted to try to get it packaged up. I still have a lot of work to do. Well, a lot. I mean, it's working, obviously. But anytime you build a distributed system that's peer-to-peer, you have edge cases. So yeah, I'm definitely going to be trying to figure those out, find those, and sort them out. But so far, it's working pretty well. And I've dealt with a lot of the weird ones that I had up front. But anyway, I'm rambling on, so I'm going to call it good. Check it out. Let me know what you think. Catch you next time.